Hi everyone. I was asked to give some help to a student on solving equations with fractions for exercise 1D. So I thought I'd put together a quick video of the two worked examples that we did in class for those who missed it. If you have any further questions after this, please track us down at school. Just be aware I'm doing this in the car while I'm at my kids' hockey game, so if there's some noise going on in the background, I'm sorry, you'll just have to cope with that. Alright, so let's start with our first question. Here we're going to look at this type of problem. And the first thing I want you to notice here is that we've got the equal sign between my two different algebraic fractions. So the way I approach these, there's a few different shortcuts that I can take. I'm going to teach you a method that sort of works for every problem. And when I'm working with algebraic fractions, my process that I can use that works for every problem is I start by getting a common denominator. So look at my two denominators here. I've got 3 and 2. So the lowest common multiple of 3 and 2 is 6. Okay, so we're going to change both of these to a 6 on the denominator. What do I multiply 3 by to get to 6? I times it by 2. And what I do to the denominator, I have to do to the numerator. Same thing on the right hand side of the equal sign. What do I do to the 2 to get to 6? I've got to times it by 3. And what I do to the denominator, I have to do to the numerator. So if we tidy this up a little bit now, I'm going to get 2 times 4x minus 2, all divided by 6, being equal to 3 times 3x minus 1, all divided by 6. Now the fact that this has got an equal sign here, this is telling me that these two expressions are equal. And we're trying to find out what x is. Now if they both have a divide by 6, the only way they can be equal is if the numerator is equal to the numerator on the other side. So we can essentially just eliminate these divide by 6's on both sides because they're the same. The only way these two expressions are going to be equal is if 2 times 4x minus 2 is equal to 3 times 3x minus 1. And now we've got rid of our algebraic fraction. So the next step that I'm going to take is expand my brackets. So times out the brackets on both sides of the equal sign. I always like to draw the arrows to remind myself what I'm doing. 2 times 4x is 8x. 2 times negative 2 is negative 4. That's the left-hand side. 3 times 3x is 9x. 3 times negative 1 is negative 3. That's my right-hand side. And then I'm going to start to rearrange my expression. And the first thing I do when I rearrange my expression is I try to get my variable on the one side. So I'm going to do something with my variable. I'm going to do something with my x's in this case to get them on the same side. And the easiest method here is choose the smallest coefficient and subtract that from both sides. So 8x take away 8x cancels out, and I just have negative 4 on the left hand side, and on the right hand side 9x take away 8x is just 1x, and I've got a minus 3. And then finally my last step is I'm going to get rid of this minus 3 by adding 3 to both sides of the equal sign. And end up with x equals negative 1. And then that's the solution to my first expression. So to recap, what did we do? Number 1, we got I don't know what I was about to write there. We got a common denominator. Step 2, we expanded the brackets and collect like terms. Step 3, variables on one side. I say variables to the same side. And then step 4, rearrange by working backwards. Alright, let's have a look at another problem. We're going to follow the same steps, but I'm just going to drag this down my screen and start working down here instead. Alright, so using the same process, the first thing I'm going to do is I'm going to get a common denominator. Alright, so unfortunately my two examples both have the same numbers here. My common denominator of 3 and with 3 and 2, or my lowest common multiple of 3 and 2, is going to be 6 again. So I'm going to multiply that by 2. I'm going to multiply the top line by 2. On the second fraction, I'm going to multiply by 3. Multiply my numerator by 3. Okay, so then it would become 2 times x plus 2, all divided by 6, minus 3 times 2x minus 1, all divided by 6, which is equal to 4. And what I want to remember here is now that these have the same common denominator, I can write them as a single expression over one single denominator. So I've got the first numerator minus the second numerator, all divided by 6. Alright, now a little bit different to before, because before we had a 6 on both sides of the equal sign, and we just got rid of it because it was the same on both sides of the equal sign. Here though, we don't have a 6 on both sides of the equal sign. We've only got a divide by 6 on the left hand side. And we've got this 4 on the right hand side. So I'm going to manage this by moving this divide by 6 on the left hand side, and I'm going to multiply both sides of the expression by 6. So I'm keeping that balance. What I do to one side of the equation, I do to the other. That times by 6 and divide by 6 cancel each other out, and I'm left with 2 times x plus 2 minus 3 times 2x minus 1 equal to 24. Alright, we have got our common denominator and managed that. Now we're going to expand and collect our like terms. So expanding my brackets, drawing my arrows to remind me that I have to multiply everything by the bit inside the brackets. And this part here is pretty important to remember. I'm multiplying by -3, not just 3. So 2 times x is 2x, 2 times 2 is 4, -3 times 2x is -6x, and -3 times -1 is +3. And we don't have to do anything to the right hand side. And now we're going to collect our like terms. So my like terms are the 2x and the -6x, and the +4 and the +3. Okay, 2x take away 6x is -4x, and 4 plus 3 is 7. And on my right hand side, I've got 24. So we manage the fractions, we expand the brackets, we collect our like terms. Now I am just going to rearrange this expression. I would start by subtracting 7 from both sides, which gives me -4x equals 17, and then finally divide both sides by -4, which ends up with x equals -17 over 4. And I usually put the negative with the numerator. I suppose that's considered more mathematically normal, better formatting. Not necessary. You can put it with the top, you can put it with the bottom, you can stick it out the front. My preference is that you stick the negative signs with the numerator, just to avoid doubling up and using the same negative sign more than once. Okay, that's the end of the video. Hope it made sense.